Hi, my name is Jeremy Schulman. You can find me on Twitter as Network Automaniac. And in this tutorial, what I'm going to do is cover a new package that I've created or a library that allows me to asynchronously communicate with the ipfabric product. So what I've got here is a demo system from ipfabric. I don't work for ipfabric, but they've given me this demo system that has a lot of data in it, so I can kind of mess around with their API. And I've created a library that lets me connect to that using the HTTPX package kind of under the hood. So I'm going to show you a couple of really cool things that you can do, and I'm going to use PyCharm as my environment. So let's just get started with that. So I'm just going to load up PyCharm, and I'm going to quickly create a new project. So I'll just call this demo, and I'm going to be using Python 3.8. If you're doing anything with async IO, I recommend you use 3.8 or later. So once we get this up and running, what I'll do is I will then install in my environment the package that I've created. So we can just go into the Python interpreter. You can see the virtualized environment only has two packages, so I'm going to add one. I'm going to go aio-ipfabric and install that. So that's done. And what you can see is, sure enough, there's HTTPX. All right. So the first thing that I'm going to do is it's a little bit bigger, and we'll say from aio-ipfabric import ipfabric client, and I'm going to create just kind of a main running coroutine. So async def demo, and we'll say ipfabric client. We're going to await login, so that's going to asynchronously run the HTTP code to log in with credentials, and say hello, just say connected to ipfabric, and then we'll await the IPF logout. And really, that's just shutting down the asynchronous IO connection. So not a lot of magic here. We're going to need async IO eventually. So what I'm going to do here is I'm going to activate my virtual environment. I'm going to create an environment file with some environment variables that this client uses. So first thing you need is the address to your server. Your username, in my case, is admin, and the password is admin12345. Okay. Not a lot of magic there. I'm using bash, so I can just set my environment, as you can see there. And I'm going to install IPython so we can use this to interactively, play around with this code that I'm writing. All right, so let's do IPython and load in the main file. All right, so in the main file, remember we have this kind of demo. And all I'm going to do is, if I await demo, that's going to log in, connect to ipfabric, close it down. That just lets me know that I've set up my environment, everything's good. And if I wanted to do that kind of step by step, I could do that. And just to show you the kind of the moving parts. I could say await ipfabric login. And here, we can see that we've got a token. So we've logged in. And, there's a lot of built-ins to ipfabric client. There's like fetch devices. So if I ran ipfabric fetch devices, again, fetch devices, this is a coroutine. So if I wanted to get all the devices, I could say, await IPF fetch devices. And I can see that I have 647 devices. So if I go to inventory devices, sure enough, 647. All right. So the client library, provides some of these built-in, functions, but there are just an enormous amount of endpoints and tables and capabilities inside ipfabric. So I'm going to demonstrate a very common use case that I see again and again and again people working on. They'll use Ansible or Nornir or whatever they want to do to harvest data from the network. And that's basically what ipfabric does. It's going to harvest a ton of data. So you can see that there's inventory. You can see that I have all of the interfaces, for every device with all my descriptions and state and whatnot. You have a bunch of stuff. So what I'm going to do is I'm going to build a function that for a given device, I'm going to collect a whole bunch of stuff concurrently. So that's what I want to do concurrently. I want to collect the device inventory for it, the interfaces. I'm going to collect the VLANs about a device, and I'm going to collect the managed IP addresses that are associated to a device. So I'm going to do all that. And I'm going to do it concurrently so that all of that data is fetched kind of quote all at the same time. And if you weren't using async IO, you could do that like with threads, but those are kind of heavyweight. And I really kind of want to show you how this is done with async IO. All right, so strap in. This is going to get fun. All right, so the first thing we want to do is I'm going to make a function called async def. Fetch device info. And it's going to be given a host name. And so, again, we're going to connect to it. And now what we want to do is we want to do three things. We want to, get the inventory record. We're going to want to get the interfaces for the device. We want to get the VLANs for the device. And let's say we want to get the managed IPs assigned to the device. All right, so let's say we want to do those things. So, and we want to do them concurrently. So we know there is a fetch devices method. So we're not going to run it here. We're just going to create the coroutine, because what we want to do is we want to create coroutines for each of these steps and then run them concurrently. So I'm going to call this device task. And in this case, what I want to do is I only want to get the device that matches this host name. And that's going to be true for all of these function calls. So I'm going to create a filter. And I am going to create a filter using ipfabric's filtering mechanism. And here I'm going to say host name is equal to, and it's going to match the host name string. Okay, so ipfabric has a very sophisticated filtering mechanism. Just to show you what that kind of looks under the hood. If I do ipfabric parse filter, this is a static method, so I can do this. I could say host name is equal to leaf 1. And really what the API requires is kind of the column name, and then they've kind of got this matching criteria. So this parse filter function kind of takes a nice human readable thing and turns it into the data structure that the API requires. Just kind of a sidetrack. All of these APIs support this column called hostname. And I can show you that here. If I go into devices and I click the table description, you can see that it has a column called hostname. And this shows you, this is the host name. So I want to match exactly on the host name that, that I'm looking for this device. Okay. So in this case, I'm going to say, give me the host name. And so with this, I'm going to say filters is equal to filter host name. Now this particular method, if we look at it, it is a table API, which I'll get back to in a minute. This is a decorator. And what's being passed to this, this coroutine is a dictionary that has all of the fields that the API supports. What do I mean by fields? Table fields. Here you can see the table fields. We have columns, filters, pagination, snapshot, and reports. And some of these fields are required, like the snapshot you must provide, and the columns you must provide because it says, what data do you want to get back? And the filters are any kind of filtering you want to do to filter against the table. So what this table API does, this decorator, is it kind of fills in some of those defaults. And if you provide something, it'll fill it into that request structure. And here you can see this fetch devices. By default, it's going to give you back these columns. And then all you can see here, it's just executing a post against the devices endpoint. Which, if you looked at this is just tables, inventory, devices, and it returns the result. And what this decorator does as well is it kind of unravels the response and gives you back the body payload. There's more to it, but we'll kind of stop there. All right. So this is going to just give me the task. Again, this is not going to execute it. It's just going to give me the task. And if I wanted to execute this, what I'm going to do is I'm going to use async.io gather. So this is going to allow me to run a bunch of tasks. For right now, I'm just going to get back the devices task. And I'm going to say return exceptions equal true. And what that means is if there's an error in anything I'm doing here, it's going to return the exception rather than kind of blowing it up. And that lets me examine some of those errors. And then I'm going to just say return results. Okay. So really what's going to happen here is it's going to log in. It's going to fetch the singular record from the devices table. And that's going to happen here. It's going to log out, and then it's going to return me these results. All right. So I'm going to say results is equal to await fetch device info. And now in this case, I need to pick a device. So there's a device that I've been using, which is L77R7 Leaf 1. Okay. So I have these results. What did I do? Oh, I forgot to do await. So, gather actually returns back a future. So, if you have to await it to actually make it all run. So, my bad. And just so I don't have to type this over and over again, I'm just going to say example host name. There, so I have to type it again and again. All right, so I'm going to say results is await fetch device info, example host name. All right, so you can see it fetched me that single record. Right, this is the single record. So results is going to be a list because gather returns a list. And in this case, this is the first item in that list. So if I said, give me the first item, you can see that it gives me the device inventory table. And since my filter only gave me one record, as I expected, that's why I only have one record here. Okay, well, let's do something interesting like, well, what if we didn't have a built-in function that's giving me this capability? Let's say I wanted to do one from scratch. Okay, so I'm going to make a function called async def fetch device interfaces. And here I'm going to pass it the IPF client, and I am going to pass it request, which is a dictionary, and this is going to return a response. This is an HTTPX response. Now, why does it look like this? It looks like this because I'm going to basically mimic, one of these, right? So again, I'm going to take advantage of this table API, which kind of does kind of the building and the processing of the response. So I'm going to say table API. Okay, and we know that we're going to return the await of the API post of a given URL, and JSON is the request. Okay, now what is the URL? Okay, let's get into it. So in this case, if I hit question mark here, I can see this is the URL. So I want the stuff after v1, so I'll capture that. All right, and now I have to say which columns I want returned. So what I'll do is I'll just kind of copy all of these columns. So I'll say columns is equal to blah, and then I'll use my editor to make this nice again. So there's a lot of stuff in here I don't really care about. I don't need the ID, serial number, or the host name of the record because I know that. I don't need the site key or the site name because I have that from my device inventory, but I do want the L1 state, the L2 state, pretty much everything else I want. Okay. And again, kind of going back to this table, you can see like the L1 state, the L2 state, you know, the description field, you know, these are all the things that you might want, you know, from this table. Okay. So that looks good. And what we want to do is we want to put these columns into this request. And to do that, I will do this from table fields. So I'm going to say request table fields columns is equal to columns. And really all this is just, you know, an enumerator that kind of gives my string so I don't mistype or misspell fields because I do that all the time. So that's going to set that in here, and then we should be done. So it's going to return this, and we should be good. So what I'm going to do is I'm going to say interfaces task is fetch device interfaces. I'm going to pass it the IPF, and I'm going to say filters is equal to filters hostname as I did before. Okay. And again, because I defined this with this table API, it knows what to do with its filters. All right. So now I have a new task. And this is going to be my interfaces task. All right. So it's going to run both of these things in parallel and return me, you know, now a list with 2 items in it. If it all goes according to plan. So we'll say results is equal to await fetch device info, example hostname. See, I've got 2 items in my results. And if I look at results, these are all my interfaces now. And these are the interfaces just for that device. Okay. So I can do the same thing again, you know, like say with VLANs. You know, if I wanted to know like, well, what are all my VLANs? Go to VLANs, and I'm going to repeat the process. So again, I'll copy the table description. Oops. What I want is this table. So if I were to actually do this manually, so you can see it. These are, you know, the 10 items for this VLAN. And again, if I hit question mark, it's going to show you exactly what I want. So this is the endpoint that I want. Tables VLAN. So more or less, I'm just going to copy and paste this. Boink. Fetch device VLANs. Copy that. Put this here. Right. And again, let's go get a copy of the columns that we want. And get rid of this. Paste that. Reformat it. And again, I'll get rid of the things that I don't really care about because I don't. All right. Very simple. Bing, bang, boom. Same process. So You know, I don't need to actually do this step like you're seeing it here. I could just put, fetch VLANs here if I really wanted to, which I'm going to do now. So I'll just say filters is equal to filter hostname. And again, I didn't need to do this. I can just put it, here, fetch interfaces, IPF, filters, filter hostname. I don't have to create those tasks, one at a time. I could just, stick them here in the gather function, which I'm going to do. So in this case, fetch devices. Filters equals filter hostname. All right. So far, so good. All right, let's try that. Results is await fetch device info. All right, results. Let's look at the last one. And you can see that these are the VLANs. All right, if I wanted to print out the VLAN name, so VLANs is results. Last one, I could say, we could do something fun. We could do something with tabulate. Let's do that. Install tabulate. From tabulate, import tabulate. So if I wanted to print out this VLAN table just as it was, I could say headers is equal to, let's say, VLANs keys. So that's going to be our headers. So I could say print tabulate headings. Headers is equal to headers. And I could do tabular data. Tabular data. Help tabulate. Tabular data, right? Print tabulate tabular data. Okay, so what we want is just the values of VLANs. So we want the record values for record in VLANs. And the headers are headers. Let's see if this works. Well, it looks like these are some very long strings. So let's kind of abort on that. From pretty print, import pretty print as pp VLANs. All right. So you can see, like, these are the VLANs. And there's 10 of them, just as we expected. Here. All right. We'll do one more and then we'll be done. Again, this is, the interfaces associated to a device. So I'm going to, again, get this here. And we'll do this, copy and paste. IP adders. Copy that. Nope, did not copy correctly. Copy. Oh, come on. The copy and pasting, sometimes not so great. Copy. There we go. All right, and the columns that we want are going to, again, come from this output. So I'm just going to copy and paste it. Always try to. Columns is equal to this. That looks great. So let's reformat it. and get rid of the things we don't want again. We do want the interface name. We don't need this. The rest of that looks pretty good. All right, device IP adders. Okay, and we'll do this. Fetch IP adders, filters is equal to filter hostname. All right, last one. Let's make sure it works. Results. Await. Fetch device info. Example hostname. Results. -1. Oh, we got an error. So let's see what the error was. We can look at the response text. I can see that the columns field I messed up. So what did I do wrong here? Oh, trailing commas. Oh, that'll kill you every time. So it was treating it as a tuple. Very bad. It's very common copy paste mistake. Results. Wait, fetch device info. And results -1. All right, so we can see that we got our interface and our IP address, and these are all of our interfaces. So let's see if that seems like it's the right answer. Should be 6 of them. So let's make sure that's true. Should be true. Yep, sure enough, 6. Okay. So again, what am I trying to show you? I'm trying to show you that you can execute multiple HTTP calls simultaneously using async IO gather. Again, each of these are just coroutines. These are HTTPX asynchronous coroutines. Under the hood, you can see, that's what these are. The rest of what I'm showing you is really aspects of this ipfabric client that I've written just to make programming and interaction with the ipfabric system easier to do as a programmer. So if you are using ipfabric or looking at using ipfabric and you would like a Python client, this is the one that I'm building, and it's available on GitHub, and if you want to check it out, please do. And again, any questions you might have about asynchronous IO or what I'm doing here, please just post them in the comments under the video. Thanks.